Hello class, welcome to Algebra Lesson 3-4, which is all about arithmetic sequences. By the end of this lesson, you should be able to identify and describe arithmetic sequences. Now, some of you might be reading the screen and thinking, Miss Johnson, you've gone crazy. That word, that is pronounced arithmetic, and you're not wrong. That is spelled exactly the same way, so I definitely understand why you would say arithmetic sequences. However, when we are talking about sequences, and this word is right in front of it, we change the pronunciation so that way we know we are talking about something a little different. So we pronounce it arithmetic sequences rather than arithmetic sequences. Okay, so arithmetic. Example 1, connect sequences and functions. So if we look at this ordered list, 26, 39, 52, 65, and 78, we want to know, is this an arithmetic sequence? Now, first of all, let's talk about a little bit of vocab so that way we know what this question is asking us. So first of all, a sequence is any ordered list of numbers that form a pattern. So what that means is I can't change the order the numbers are in. So I can't say, I'm going to do 39 first and then 65 and I feel like 26, maybe 78. And you know what? I'll end with 52. That is not an option. Okay, so sequences, the order matters. Then each number listed in the sequence is called a term. So 26 is a term, 39 is a term, 52 is a term, 65 is a term, and 78, another term. Okay, so our first term is 26. That's the first one listed for us. And an arithmetic sequence is classified by, do the numbers all change by the same amount each time? So going from 26 up to the number 39, I have to add 13. And in order for this to be an arithmetic sequence, I have to add 13 every time to get from one number to the next. So 39 to 52, that is adding 13. 52 to 65, I added 13. 65 to 78, again, I added 13. So yes, this is considered an arithmetic sequence. And the last little bit of vocab that I'll share with you is this number 13 down here, whatever it changes by, that is called the common difference. Sometimes I like to abbreviate it on my work as CD, the common difference. That's however much it's either going up or going down by. So even though it has common difference, normally we associate difference with subtraction. In this case, it's just whatever the number is between each term in the sequence. Okay, so let's talk about how are sequences related to functions. So you can think of a sequence as a function where the domain is restricted. So that means we're only going to use like those nice natural numbers. So those counting numbers, we have 1, 2, 3, 4, 5, 6, and it keeps going on and on and on. We're not going to pick something like 5.5. We're not going to pick 0. We're not going to pick negative something. We're only going to choose those nice counting numbers when we're dealing with sequences, okay? It's really important for you to remember that, okay? So sequences, the domain is always going to be natural numbers. Okay, so that means x is greater than 0. All right, so for the sequence 26, 39, 52, 65, and 78, n represents whatever term number in the sequence we're talking about. So if I say, let a of n equal the value of the nth term. So say I want like the 100th term, or I want the 200th term, or maybe I want you to have the choice to pick what term in the sequence we're talking about. That's why we use a variable. That allows for people to choose their own number. But if I'm talking about the first term, I'm going to write a capital A, to represent arithmetic, okay? And then you do parentheses, and just like our function notation where we practice plugging numbers in, like this would have looked something like this as a function, but we're plugging 1 in to represent that we're talking about the first term in the sequence, the first number in that list of numbers. So our first term is 26. Our second term is 39. Our third term is 52. So this is how you would write that. And you can keep going on and on and on. Okay? If you want a slightly faster way to represent the terms in the sequence, I typically use this way down here. It's called the subscript notation. So I use the little a and then whatever number I'm talking about. So if I'm talking about the first term, I would say a subscript 1 equals 26. Or I could say a subscript 3 equals 52. And you can see that they did the second term is 39. That's how you would read this out loud. And same with up here. The second term is 39. The first term is 26. My bad. I swear I know my numbers, guys. Okay, so you can use either the function or the subscript notation in your assignment and on your test. I will accept both. All right, so we've talked about sequences. Now let's talk about another fun math word, recursive. Okay, so in math, recursive means when you repeat a process over and over again. So back in elementary school, before you learned how to multiply, like instead of saying 2 times 4, you would say 2 plus 2 plus 2 plus 2, and it got really annoying, right? It takes up so much time. So mathematicians came up with recursive formulas that can speed up the process for you. So like multiplication is one example. But let's talk about how we can use a recursive formula for an arithmetic sequence. So first of all, a subscript 1 means the first term in the sequence. A subscript n means that you get to tell me what number in the sequence we're working with. And when I say you get to tell me, I mean, please use the variable n. And unless I tell you to actually pick a real number, please use n. When you're writing your formulas, you should always be using a and n for arithmetic sequences. So I'm going to say a subscript n equals a subscript n minus 1. So if we think about that, if I am talking about the second term and I want to find that, I would do a subscript 2 equals a subscript 2 minus 1 plus whatever our common difference is. So our second term is, what's 2 minus 1? That's the same thing as saying 1 plus d. So I can say that my second term is just my first term plus the common difference. Okay? And this works for any number. So if I said like a of 50, then I would have a 50 minus 1 plus d, and a of 50 would be saying whatever the 49th term is plus the common difference. Okay? So this is what is called the recursive formula, and this is something that you want to have memorized. Hint, 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 hint. Memorize this. This is the recursive formula, and memorize that name too, because I'm going to introduce another formula a little bit later, okay? So this is another fun flashcard activity if you need flashcards to help you remember these different words. So example 2, let's apply the recursive formula. We have, what is a recursive formula for the height above the ground of the nth step of the pyramid shown? Okay, so we're going to write a recursive formula, and then we want to use that recursive formula to find the height above the ground of the third step. So we have this lovely picture, and we know that each step is 26 centimeters tall. So remember our recursive formula, we said a n, subscript n, because we're just doing a generic formula. It's like using x in our functions. And then we're going to say a n minus 1 plus whatever our common difference is. So if I want to write a recursive formula, I'm going to use the generic a of n equals a n minus 1. And then what is my common difference? Well, my common difference is going to be whatever the height of each step is. So I'm going to say 26. So this is my recursive formula, and that's all I have to do for that first part of the question. Then the second part of the question says use the recursive formula. Okay, so we want to use that formula to find the height above the ground the third step is. So I'm going to say a subscript 3 equals a, and then 3 minus 1 plus d. And by d, I mean we know what d is, so let me try this again. A subscript 3 minus 1 plus 26. So then I'm going to say a subscript 3 equals a subscript 2 plus 26. Okay, perfect. I now know how to find my a subscript 3, except one problem. I don't know what a subscript 2 is yet. So what I have to do is I also have to find a subscript 2. So a subscript 2 is the same as saying a subscript 2 minus 1, which is just 1, plus 26. So our second term would just be a1 is 26, right? That's how high the first step is. So I'd say 26 plus 26. So my second term is 52. So now I can go back to my third step and say 52 plus 26. And so I know the third step is in fact 78 centimeters tall. And if you want to hear something funny, I was just looking at my notes for this lesson, and I wrote down the wrong label in my notes. I wrote feet. Can you imagine a third step being 78 feet tall? That would be ridiculous. This is why it's always good to double check your work, because 78 feet versus 78 centimeters, big difference. All right, moving on. Question 2, this one's for you to try. Write a recursive formula to represent the total height of the nth stair above the ground if the height of each stair is 18 centimeters. Good luck. Okay, for this problem, hopefully you said a subscript n equals a subscript n minus 1 plus 18, and maybe you had a hard time typing that in. I totally understand, because that is a pain to type in, and typing math things into a computer, not always easy. So I hope you just did your best, and what I care most about is not how you type in the answer for me to see, but what you have written on your paper. So if this is not the answer that you got, please make sure you reach out for some help, whether it's from me or from a friend. All right, so we talked about the recursive formula. Now let's talk about the explicit formula. So explicit formula is going to be the one that we tend to like the most, because like on that last question, you know how we were trying to find the third step, but before we could do that, we also had to find the second step and the first step. The explicit formula speeds up the process. So if I want the 100th step, I don't have to find the height of every single step in front of it. I can jump right to the 100th step. Okay, so explicit formulas really speed up the process. Okay, so we have a of n equals our first term plus, and then that n minus 1 gets moved over on its own. So it used to be a and then subscript n minus 1. For explicit, it gets its own special parentheses. Okay, so I'm going to say our first term plus quantity of n minus 1 times whatever the common difference is. So this is another thing that you're going to want to memorize. So please make sure this is written in your notes somewhere, or you take a screenshot. Do something. Don't just sit there and stare at the screen and think, will Miss Johnson ever stop talking? It's okay to think that, but do something with this information. Example 3, apply the explicit formula. The cost of renting a bicycle is given in the table. How can you represent the rental cost using an explicit formula? So I'm going to start by using what I just learned on that last page. In case you forgot what we learned on the last page, it was this fun explicit formula. So I'm going to say a subscript n equals our first term plus n minus 1 times d. All right, now let's start plugging things in. When we're writing a formula, I'm always going to leave that a subscript n. And then what's my first term? When you're given a table, your first term is going to be represented first. I don't know any other way to really say that. So here we actually have the number 1 even for you. So when we look at our first term, we see that the cost was 26. So a subscript 1 equals 26 plus, and then we're going to leave n minus 1 all like it is, okay, because we're just talking about in terms of n. And then my d term, to go from 26 to 38, I add 12, 38 to 50, add 12, 50 to 60, add 12. My common difference is 12. So now what I'm going to do is I'm just going to simplify this. I'm going to distribute that 12. So 12 times n is 12n. And then 12 times a negative 1 is minus 12. And then I'm going to combine my like terms. So 26 minus 12 is 14 plus 12n. And that is all that you have to do to write your explicit formula. If you swapped these and you said a subscript n equals 12n plus 14, perfect. Same thing. I often put my variable first. It is okay that it is not first, but that's just my own personal habit, is to put that n, the variable term first. The variable with the, you know what I'm trying to say. Words are tough. It's okay to put the 12n first and the 14 second. You get the same thing. All right, question 3. Your turn to write an explicit formula. The cost to rent a bike is $28 for the first day, plus $2 for each day after that. Write an explicit formula for the rental cost for n days. Good luck. All right, for this one, hopefully you ended up with a of n equals 28 plus 2n. This one was a little simplified for us because we already have the amount of money it changes each day. So we can just take the total from the first day and add 2 times however many days right on to the end of it. So now take that explicit formula and find the cost for renting the bike for 8 days. Good luck. All right, for this problem, hopefully you ended up with $44. If you have questions about this or the problem right before, please let me know. I'm more than happy to help you. Let's move on to example 4. It's more practice with writing an explicit formula from a recursive formula. So in this case, we have a staircase again because apparently the book loves stairs. Not sure why. I have no explanation. Okay, so the recursive formula for the height above the ground of the nth step of the stairs shown is a of n equals a, n minus 1, plus 4. And our first step is not actually the same height. Look at that. We have a first step that's actually 7 inches rather than the 4 inches that the rest of the steps are. So our process is going to change just a tiny bit. So we'd say a of 1 equals 7. And then a subscript n equals a subscript n minus 1 plus 4. So what we would do is we would take that information we know, because our common difference is 4, we'd just plug it into the explicit formula. So our first term is 7. So I'm going to say a of n equals 7 plus, and then n minus 1 times 4. And what you can do is you can simplify that formula even a little further. So I would have 4n minus 4, so a of n equals 3 plus 4n. And that is all you have to do. So that's just combining what we've already learned into yet another word problem about stairs. All right, now I want you to take the recursive formula here, the information we know from these two pieces here. I'm just going to draw the line to help you separate between the two pieces of information. And I want you to write an explicit formula using that information. Good luck. All right, for this problem, hopefully you ended up at a subscript n equals 13 minus 3n. I showed my work there. The common difference was a negative 3, so I distributed a negative 3, and my first term was 10. Then I just combined my like terms. So if you have questions about that, please don't hesitate to ask for some help. And now let's do the other way. Let's take an explicit formula and let's turn it into a recursive formula. So the explicit formula for an arithmetic sequence is a of n equals 1 plus 1/2 n. Okay, so first step, identify the common difference. The common difference is always the number with the n. So my d value equals 1/2. Then you want to find the first term in the sequence. So what you're going to do is you're going to take that sequence that you were given and you're going to substitute 1 in. So a of 1 equals 1 plus 1/2, and then I'm going to plug a 1 in. So our first term equals 1 plus 1/2, or 3/2. I'm not sure why I rewrote it when the book had it nicely typed for you. I just felt like it. So then step 3, write the recursive formula. Once you know your first term and once you know your common difference, you can write either of the formulas. So all you're going to do is you are going to, for a recursive formula, you list your first term. So you can see down below that they state A1, our first term, equals 3/2, and our in order to find the nth term, you would use A subscript n equals n minus 1 plus 1/2. So this is what you would have to include for a recursive formula. So you'd have to type both of these pieces of information in, and usually we use a semicolon. That's not a J. Please don't mistake that for a J. That is a semicolon. We use a semicolon to split up those two pieces of information, okay? Now, I want you to take this information, apply those same steps, and turn this explicit sequence into a recursive formula. Good luck! For your recursive formula, hopefully you found the first term was 11, and your recursive formula would be A subscript n equals A subscript n minus 1 plus 3. If you have questions on how I got there, please don't hesitate to ask for some help. I'm more than happy to assist you. Here's a nice little summary detailing the differences between recursive and explicit, and please make sure you have these things memorized and you are asking questions as you need to. I hope you guys have a fantastic day.